Hi everyone, welcome to our lesson. Final exam revision questions, day 1. So every day we are planning to answer 2 questions with you. Question 1, multiple choice question, and question 2, normal question. As you know, people, before final exam, you should try. So let's try with our revision questions. Please go to link, get all questions, try first, and then come and listen all answers. I hope it's going to help you. All right, so question 1. Today we are studying with electrostatics. Question 1, multiple choice question 1. Two identical metal spheres P and R, okay. And then spheres are contact, okay. They are just touching each other. And then if the charge on sphere R after the separation is Q, the charge on sphere P after separation is what? That's our question. So after contact each other, after touching each other, what do we know? They are gonna have same charge. As you know, they're gonna have same charge. Initially, maybe they have different charge, but always when they touch each other, they are having same charge. Because of that, we are saying our answer is A. That's our answer. 2 marks you have. Today's paper totaled 19 marks. This question 2 marks, always multiple choice questions with 2 marks. And then next question you will have with 17 marks. All right, so next question, question 2. We have 2 small charge spheres, A and B. A and B. So first of all, sphere A and B 0,2 meters from each other, from the distance between from each other, and then B 0,1 meter away from point M. Okay, all diagram you see. And then let's see what they ask. All charge given, charge of A, charge of B, everything is given. M is a point, all right. There's no charge, nothing there, just point M. Distance from B, 0.1 meter, all right. So what they ask? They're asking you, calculate the number of electrons in sphere A. We're calculating number of electrons. Formula is N is equal to charge over E. Charge of A we are using. E is charge of electron, as you know. So it is negative because, as you see it in the diagram, it is given negative 4 times 10 to the power of negative 6 coulombs. And then over negative 1.6 times 10 to the power of negative 9. So if your charge is positive, for E, you are going to use also positive 1.6. You remember that one? Because we are getting always positive number or number of electrons. So you are calculating formula is 1 mark, solution is 1 mark, and then final answer is 1 mark. As you see, there is no unit because charge of coulomb, charge of sphere A is coulomb, units coulomb, and then charge of electron also coulomb, and coulombs cancel each other. So answer is 2,5 times 10 to the power of 13 electrons, you can say, but there is no unit. We don't need units. 3 marks coming from this, 5 marks total now. And then next question, calculate the magnitude of electrostatic force, okay, by sphere A on sphere B. Okay, we are looking for electrostatic force on sphere B by sphere A. So that's our question, another 3 marks. So how we are going to calculate this one? We are using our formula, force equals K times Q1 times Q2 over R square. As you know, K is constant number, coulombs constant. Q1 is charge of A, Q2 charge of B, and R is distance between A and B. All right, not distance between A and M, just using distance between A and B. And then when you put all numbers, K is constant number, you can get from formula box. You can get it is constant number. And then you are calculating, as you see, for Q1 and Q2, we don't need to use negative or positive. We don't need because we are using always positive. You don't need to get direction of force if they ask you, because they are asking you magnitude of electrostatic force. You can use without positive or negative. When you calculate, you are getting 2,7 Newton. As you see, Newtons we should write because we have unit now. Other question, there was no unit, but now we have unit. Another 3 marks done. 2.2 done. 2.3. Describe the term electric field. So they're asking you electric field. What's electric field? Electric field is a region in space where an electric charge experience electric force. This is our definition. For definitions, nothing to do, you should memorize. Please try to memorize this one because they ask already this kind of question. 2 marks, done. Another question, next question, 5 marks. Calculate the magnitude of net electric field at point M. See, in this question, they're asking you electrostatic force, electric field definition, and then they're asking you electric field calculation, almost all type of questions for electrostatics asking here. So calculate the magnitude of net electric field at point M. So what are we gonna do? First of all, we are gonna calculate electric field because of B on M, and then we are calculating electric field because of A on point M. After that, we must just calculate together total net electric field. So first one, electric field AM, because of sphere A on M, electric field AM is equal to K times Q over R square. As you see, there is no Q1, Q2, only QA we are using. K is constant number, and then Q is 4 times 10 to the power of -6, and then 0.3. Why 0.3? Because distance between A and M total 0.3. All right, so you are calculating electric fields for point M because of A. So direction, it is negative. So negative, as you see, it says to the left. So to the left, first one. And next one, electric fields, BM, K times Q over R square, and then 9 times 10 to the power of 9, 3 times 10 to the power of -6, and 0.1, because distance between B and point M is 0.1. And you are just calculating that, and then you are getting 2.7 times 10 to the power of 6 units of, this is n times c power of -1, this is unit of electric field, to the right. As you see, to the left, to the right. Because of that, you are just using first one, bigger one is to the left, so that one is first, minus, as you see, minus to the right, you are using to the left and right, and net electric field at M, as you see, they said in definition, okay, oh, sorry, this is 0.4. When you convert it to the power of 6, it's going to be 0.4. You have 0.4 to the left, and then 0.4 to the left, and then 2.7 to the right. When you see, because this is 10 to the power of 5, this is 10 to the power of 6, as you see. Otherwise, you are going to confuse it is 4 and this is 2.7. 4 is bigger than that. No, 2.7 times. So to the right is bigger, stronger. And then you are just calculating, you are adding these two. Right side first you can write, or you can say negative that side. It's fine, you can just work on it. But final answer is 2.3 times 10 to the power of 6 times 10 to the power of 10 times c power of -1, right direction to the right. We are saying right because right side is stronger. All right, so this is our final answer, 5 marks. Or another option, as you see here, to get right, as you see, -4 times 10 to the power of 5 plus, and you are getting negative, and then you're just choosing negative side is right. If you say negative side is right, different calculations you can make, of course. And then another option for this question, same process, you're calculating E for electrostatic force. Yeah, calculating electrostatic force for each. No, they did mistake here. Electrostatic, leave it, it's fine. All right, 2.5. There is another question here now, but it is just in this question, another diagram, let's say. Charge sphere A and B and another charge sphere D. Okay, it's on the system, all right. A, B, and D we have, all right. Net electrostatic force experienced by A is 7,69 newtons. Okay, net electrostatic force, all right. And the direction is here, okay. What they ask is the charge on sphere D positive or negative? Charge on sphere D is what we know about A. Okay, as you see this way, so attracting, as you see, because of that, it is positive charge. Sphere D is positive. Let's see electrostatic force. All right, sphere D is positive. All right, they're asking you charge on D. Answer is positive. And then what's the next question? Calculate the magnitude of the charge on sphere D. They're asking you that. We know magnitude of charge on A, we know it is 7.69. So let's see our solution now. First of all, you can say F net is equal to FAD plus FAB square. So you can just write like that. So after that, FAD, you can write it here. And then, so when you calculate FAD, we know already. FAD, you can just write 7.2 from this calculation, because from vector, you know already. So FAB this way, FAD other way. And then when you square and add them, you're getting 7.69. You are getting FAD first. When you get FAD, you can say K times Q1 times QA times QD over R square. So you are just calculating from there QD. Or you can say FAD is equal to K times Q1 times Q2. Or this almost, yeah, same solution. And then you are just getting, as you see, you are calculating with another way, but different way you are calculating. You are starting with FAD, and then you are putting FAD there. It's the same process. So you are just calculating your charge on sphere by using this vector formula, vector quantity, calculating total vector. F net square is equal to FAD plus FAD square plus FAB square, and then you are calculating it as you see on solution. Or you can start with FAD. You are calculating FAD with Q, with charge of D, and then you are using that one opposite direction. So finally, you are getting your charge on sphere D. All right, first revision questions we have done. So we are going to continue with another topic next lesson. See you next lesson. Thank you very much. Have a nice day. If you have any question, you can ask me on just on YouTube on comment. You can ask me if you have any question. I will try to help. Thank you very much. Have a nice day, everyone.